Thank you for joining this webinar this afternoon. My name is Jane Leakes. I work for the Newton Gateway to Mathematics. We are the Impact and Knowledge Exchange arm of the Isaac Newton Institute for Mathematical Sciences. The Isaac Newton Institute, for those of you who don't know, is the UK's National Institute for Mathematical Sciences research programmes. And if you'd like to find out more about us, please do go to our website and you can find a link through to the Isaac Newton Institute site as well. So today is the first of a series of 5 short webinars on privacy enhancing technologies. And we're going to be talking about multi-party computation in a sort of discussion format with question and answers between Nigel Smart from KU Leuven and Dan Bogdanov from Cybernetica. So before that starts, I think Rob Lerney from the Digital Catapult, and we have worked in partnership with the Digital Catapult and also Nigel Smart to develop this. So Rob's just going to say a few words before passing on to Nigel and Dan. Thanks, Rob.
Thank you very much, Jane. It's a great pleasure to be here with all of you. Good to see so many people turning out for this. We are extremely pleased to be co-hosting this event with the Newton Gateway to Mathematics. We are Digital Catapult. For those of you who don't know, this is a UK research and technology organisation created by the government 8 years ago with the goal to improve the uptake of advanced digital technologies into the economy. I am the head of distributed systems, and of course that includes blockchain and all of that, where cybersecurity and cryptography have become major topics of discussion. But we want to see other people in other industries talking about advanced cryptographic technologies and understanding them better to overcome the fear so that they can start experimenting in the right way to improve business and improve uptake of these technologies. So without further ado, I'll hand over to our expert here today, Nigel Smart, who will take you in a bit more depth of what today is going to be about. Very nice to meet you all.
Okay, thank you very much. My internet connection seems to go sometimes, so if I phase out, that's just Dan can take over and start talking. Anyway, so welcome everybody. We've got currently about 114 people turned up, as well as the people who are sort of running the show. And you come from all sorts of, I just thought I'd let you know just what kind of disciplines you come from or what kind of areas. We've got people from a semiconductor industry, there's people from Marvel Semiconductors here, there's people from A-Star, which is a thing in Singapore. We have people from the Financial Conduct Authority in London. We have Kinetic, Thales, QEdit, MasterCard, Duality from the US. We have the Ministry of Defense, we have OpenMind, there is people from the NHS Digital here, people from Privitar, Ericsson, the UN Global Platform, Amazon, you know, you name it, you're here. SAP, there's shed loads of you, yeah? So we're really, really pleased, and you kind of got a good idea of the kind of groups of people that we have here. We're going to have some discussion with Dan. What I suggest you do is I've got the Q&A window open. So if you've got a really burning question, please just stick it in there and we'll try and get to it. If we don't, we can't, sorry. There's going to be some Twitter conversation, so I hope we'll continue the conversation today on Twitter, and we'll be following up. If you've got any questions on Twitter, there's going to be a tweet from the Newton Gateway in a minute about this, so just follow up, you know, do a respond on that, whatever. So let's get down to business and introduce Dan Bogdanov. Hello, Dan.
Hello, Nigel. Hello, everyone. It's a total pleasure to be here today, and especially I'm glad to see Digital Catapult on the screen. I've actually been to your offices in London a couple of years ago, and looking for ways to collaborate. So it's great to hear from you again.
Cool. Well, for those of you who don't know, Dan is one of the experts in the world on applied multi-party computation. So he's going to give us a little bit of a background on where his company is, where it is, what it does, and then we're going to go and talking about the details of multi-party computation and how it can help you solve problems in the real world in privacy. We're particularly focusing today on privacy and not other applications of multi-party computation or anything else. Okay, so Dan, what is Cybernetica? How long has it been around? What do you do? What do you sell? What?
Yeah, so Cybernetica is a company operating out of Estonia, but delivering to every kind of places in the world, including not limited to Japan, Indonesia, UK, US, Benin, a number of places really. We operate out of Estonia, but deliver to many countries. We're not like a startup sounding place. So we are a direct successor of the Estonian Academy of Sciences, the Institute of Cybernetics, founded in 1960. So this year we celebrate 60 years of history with very similar logotypes. And that was a sort of an applied research center, similar to how they are in many countries. Around 1994, during some reforms and things, people running those institutes were actually forced to make a choice whether you want to go to the academia or you are going to form a company. And several people who wanted to do practical stuff formed a company called Cybernetica, which picked up topics like cryptography, security, maritime security, radars, coast lighting, LEDs, buoys, things like that. So yeah, and if you would ask what's the business, then I would say that we take the whole innovation pipeline from fundamental research to practice and commercial sales. So we take a technology and then we put it on the market. Might take us 15 years, might be we're too early on the market, but still gonna do it.
Okay, so what's your background? Why are you in Cybernetica, and why are you interested in privacy enhancing technologies and whatever?
Yes, so I started early on as a software engineer, systems analyst, did work for a number of industries. At some point, I found a job which put me to deliver software and solutions for the Estonian Genome Foundation, where privacy was a big issue. Lots of genetic data, including health information, much like Genomics England, very close, slightly earlier was there, but still. And then I saw how much trouble these people were having with privacy. And I thought that there's gotta be a better way. And at the university, I was doing my master's and found this cool project about multi-party computation, which my supervisor gave me. And the rest is a master's thesis, PhD thesis, and then stuff just went. Sorry.
Okay, so what you need to do is explain to everybody multi-party computation, because that's the first time it's occurred. So what is multi-party computation for everyone?
Multi-party is a computation for a number of organizations or people to calculate something jointly, to reach a joint result in a way that preserves the privacy of everybody's inputs. There's also some additional properties like preserving the privacy of intermediate values and outputs and so on, so on. But the two main points I focus on is that we are jointly doing something and we're going to protect your inputs while we do it.
Okay, so do you have a standard example that you use? I always have a standard example. Do you have one?
I usually pick them based on the industry. My standard example usually involves numbers, modulo 100, and explaining how two test results, how we calculate the average of two test results from two students without the student divulging their very private scores. I use such a simple example because I usually go through the math, and it's really like early primary school math pretty much. And using that example, I always manage to explain it really quickly, but let's not go through it here. The eponymical example is usually the millionaires. So whether it's me richer or Nigel richer, and we would like to know just this one bit of result without me telling how much I got and how much Nigel has got. So although based on, yeah, that's like the standard academic example, but it can be expanded into like different pension funds calculating whether one has more assets or the other has more assets, or one is pricing a certain asset in a more expensive way than the other, or so on. So you can expand it arbitrarily.
Okay, so what was the year when you got interested in NPC and started moving?
2006. We read some of the early papers from Kramer and Demgar from Denmark, and Kramer is from Netherlands. No, So yeah, and read some of the early papers and then tried to read Canetti's life work on universal composability and didn't understand the thing and tried to do something simpler. So, and I had a background of writing networked computer games as a hobby. So I was pretty good at writing code and writing distributed systems. So I thought that I'll give it a go. And then the thing started working better than anticipated. And then I joined Cybernetica. And Cybernetica saw this as a potential thing and started supporting me growing the team. And because it was we're a very vertically integrated team. So the scientists are working next door to architects and solution engineers all the time. So I got already early on, they asked me questions, but so how can you use it in practice? So I had to very quickly make this stuff practical, which was what I did. And I think that we had like 20 people working on this at some point on various projects involving ShareMind. Right now, we do less product development and more solution development, so it's not such a big team right now.
Okay, so just to put in context for everyone kind of in the audience, 2006 is just after the famous sugar beet thing. So for those who don't know, the Danish ran a sugar beet auction using multi-party computation, which was the first deployed application of multi-party computation in the real world, where basically they run an auction and worked out who won the auction using secure computation. So the bids were kept secret. And then, yeah, so this is really on the early days. So how big's your team?
Right now, there's about, like Cybernetica itself is 180 people, but not everybody is working on these projects. We have the luxury of moving people on and off. So constantly we have about 10 people working on the technology, the legal aspects, the sales, various different kinds of this. And then when we need to deliver something to a customer, then we bring on an engineering team to do it. Okay.
So Cybernetica is famous for in this space for the ShareMind product. Yeah. So can you explain a bit about what ShareMind is? What does it do? How does it enable people to do privacy computations? Yeah. What is the difference between that and other things?
ShareMind is an application server. Think of it today when you want to run an enterprise Java application or a .NET application or a JavaScript application on some sort of a runtime. ShareMind is that runtime. You can program it to run algorithms, applications that run on MPC so that every operation is run securely with lies to little children, encrypted inputs, encrypted outputs, and nothing leaked in the middle. So ShareMind gives you that guarantee. So what you then do is you build your client application, whether mobile apps or websites or anything, and then you make them connect to ShareMind instead of your typical system. And then you can encrypt on your device, on your phone, on your endpoint, and then you can provide your encrypted input into ShareMind, which shall process it without leaking anything and give someone the encrypted result. And here I'm using encryption rather freely because it's not actually like secret sharing and everything like that, but consider it to simplify.
So is ShareMind like a database that kind of like tries to replicate SQL, or is it more like it's like a remote procedure calls that you can really do, you can do anything that isn't really more than kind of just SQL queries?
Yes, so we can do SQL queries, but we're actually more of a procedure call, remote procedure call thing. Think of it like it's a web service where you go to an endpoint and you ask it to run an operation, and then it runs an operation and returns the result. Very similar to today's standard web services, microservices, REST APIs, things like that. Oh. So, yeah, that's what it provides.
Cool. And I know you've been involved in a lot of European and US projects with all sorts of cool proofs of concept and other things. Do you want to talk us through some of the really cool applications that you've done with ShareMind and whatever? I can, if you don't pick my favorite, I'm going to ask you to talk about my favorite, but so you've got to see if you can get my favorite.
Sure. So our first real world app was for an Estonian industry consortium who wanted to calculate the health report for the industry so that everybody would be putting in securely their certain financial metrics, and you would be getting out statistics, as in how am I benchmarking myself against the industry. This is sort of that was like real companies putting in their real data about their revenues and stuff. And it was, yes, it was the IT consortium, because it was way easier to convince them to actually trust some IT system. But it was actually rather cool. And we even had a customer response, like customer feedback questionnaire, and that was also run on ShareMind. So we're very proud of that. And that was like 10 years ago. So that was, we were proud of this. Our coolest thing that everybody usually remembers is that we implemented satellite collision prediction using floating point arithmetic somewhere 2014 or something like that. And we have a very cool animated video about that. And we were really proud of the floating point thing. It was like super precise. We could even implement the standard IEEE 754 so that nobody would say that, ah, yes, you're running imprecise floating point or anything. And, you know, I still sometimes space industry people tell us, so yeah, Dan, could we really do it? Would it like really be something we could do? And then I say that the moment that I get India, Russia, European Space Agency, NASA, and the Chinese to run their satellite information into a software developed in Estonia, I will get a Nobel Peace Prize probably the next year, because there are some things that even multi-party computation can't really fix, I'm afraid. You know, but that's interesting. So our landmark case for like big data was the linking of the Estonian tax records and education records to analyze the behavior of students who were working. So there's this hypothesis that working students don't graduate the university as well, which kind of rings true, but we needed to study it for a number of reasons. And we managed to do that with millions of tax records, million of healthcare records, sorry, not healthcare, education records, and run a full statistical suite on it. So that was our first cool thing. And there's also a UK case, which I'm glad to report on. There was a case in 2016 with the Cabinet Office where we were building a very cool prototype on using MPC to, let's say, detect certain kinds of frauds, not going into too much detail. But the idea was exactly that you could pull in records from multiple government agencies and then use it to answer certain questions without infringing on the people's rights. So questions that the government would need answered, but you would need input from a number of places which shouldn't be linked together under normal circumstances. Okay,
if memory serves me right, you were also at this Financial Conduct Authority event a few years ago. Yeah. So what did you do at that event?
Yes, so there's obviously the anti-money laundering is a rather big thing these days, and we also try to look at what is how could it make the banks work together. So it's like every organization who has a local view of things could use multi-party computation to build a global view of things without having to give up their own business secrets. So in finance, obviously it's the banks. To get the banks to work with each other and say that, okay, I have this shaky transaction, you have this shaky transaction, Tim there has 10 more shaky transactions. If we put it all together, we see that, okay, it's actually fine. It's just something behaving really interestingly, doing some fancy new business model, but maybe Tim has records that show that my transactions here are so obviously fraudulent that you couldn't do this. And then the other thing is know your customer, obviously, because some banks actually have so many offices in so different countries that you don't know anymore whether a certain person is your customer or not. So if you could actually pull this information together using MPC, you could say that, okay, I actually have this person as my customer elsewhere. So maybe I also have some fraud history about them elsewhere. And obviously you can extrapolate this to use cases in healthcare, which I'm very heavily working on these days. And yeah, more probably. The nice thing is that MPC is a sort of this greater good, common good technology. If we just all would work together, then MPC would solve the data protection concerns. It wouldn't solve the ethical concerns, and it wouldn't solve the concerns if the data is crap to begin with. Sorry, pardon my language here.
Okay, just to let everyone know, it's easier if you type questions in the quick Q&A box, because then we know when we've answered them. Okay, so that's just like, because I can then go, it's been answered by someone. So yeah, so otherwise it just becomes a stream and whatever. Okay, so before we get on to, there's some really interesting questions coming up in the Q&A, which we're not going to, I want to come to a bit later on. So one thing that you do that so people don't know, I've got this company called Unbound, which also does NPC, but it does it in a completely different way. So one of the things that we had before we set up Unbound was this idea that it was really hard to do NPC in the commercial world, because to actually sell an NPC solution in the traditional sense is quite hard, because you have to get multiple parties to buy the stuff at the same time. So how do you go about actually selling, what's the process of selling this system? Because in some sense you need to get 2 or 3 parties to buy your stuff, agree to do something, and then kind of how do you, there's kind of like a chicken and egg there. How do you solve that problem?
It's a very cool problem, and one of the reasons why we've been having some success solving it is that for 15+ years we've been selling e-government backbone software, like to places where we build up e-government and so data exchange between various organizations or companies. So places like Ukraine, Azerbaijan, Benin, if several, like some Japanese banks who have been building systems on top of some Cybernetica's other software. ShareMind is not the only thing we do. And these are distributed systems, many of them. They're complicated systems. They're not like custom off-the-shelf stuff. So it always has a painful integration project related to it. So we've been doing these painful integration projects for years. So the in-house thinking is sort of, yes, this is hard to sell. We need to tell the customer very honestly in advance that this is how you're going to deploy this. You are going to have to build that, that, and that. It's not going to be a magic box that you can buy from us and you put it in your rack and then it's going to be fire and forget. And that does make our market slightly smaller, because yes, obviously, if I wanted to do a startup hockey stick style growth thing, then I would need something that's fire and forget. It's an appliance. I drop it in my rack. I buy it off of Amazon or something like this. And the trouble with getting this stuff to run in a way that you buy it off from Amazon is that technically you shouldn't be running all your NPC nodes on the same Amazon cloud if you want the proper security. That means that you need to do this on top of Amazon, Azure, Alibaba, if you want the A character clouds, for example. You can also have some other like G clouds and things like that. But the idea is that setting up is a sort of a burden, and somebody needs to be the champion. Somebody needs to say that we are going to build this service and you're going to be my friends and we are going to play in this game together. And might be that I'm the one who buys all the licenses. So for example, when we draft our contracts, then we assume that we have one customer and the contract says that they have the right to sub-license X amount of servers.
Okay, so you still go to the one, you kind of go like, there's going to be one person who buys this stuff and then it's their responsibility to work out who the other parties are in some sense.
Yeah, and we obviously consult them all the way. We tell them, yes, this is how much it's going to probably cost. This is the possible economical business models, how you make this work. But we need somebody who takes the lead and designs the service. You can quickly figure out that this can be a co-op or a consortium of some kind. So these people would say, we come together, we found some sort of a thing, and then this thing is the one that buys, and we put together a governance board, and then they go on and work on it, and then they put it in place. Okay. And yeah, for example, if you're a number of banks, then you can do something like this. You found something new, whether it's a non-profit or whatever, and then you just run it out of that and use it as a governance body, because in MPC, it's also important that everybody behaves in a certain manner, right? There are some security assumptions to MPC. So having a sort of a governance model to ensure that these are followed is critical anyway.
Okay, cool. So, so to kind of a follow-up on this kind of sales kind of, how do you get, because there's going to be people in the audience here who are kind of going like, how can I use this? How can I convince people to use this technology in my company? What is usually done in the kind of startup world is, or basically in every business, is that you have to identify what is the pain point that your product actually solves for the customer, and then there you use that, because we hear that you can never sell security. No one wants to pay for security. What they do is they pay for having their pain reduced. So how do you saying you're going to give privacy to people? Well, do you know what? Who cares? Like, privacy doesn't make bucks. So how do you sell increasing privacy for people on the basis of the usual thing as this is a pain point for a company, you need to spend money on it?
Right, that's a very good question, and this is something that, again, 10 years of trying to do this has given some insights. So first of all, sometimes, again, based on the Cybernetica business model, where we also put in the consulting and integration thing in it, we're both the technology provider and the integrator. We would like to have other people integrate our technology, but we seem to be somewhat good at it. So we do a lot of those projects. But the answer here is that we start with understanding the business process around it. We start with understanding the business model. And then sometimes we even go as deep as try to understand what's the business that the customer tries to build around MPC. In the worst case, we shoot ourselves in the foot day one and say that, yep, sorry, no, you don't need MPC. We are so sorry for saying that, and this is not totally against my business interests, but in 5 years, you might actually thank me for not making an investment that you shouldn't have done. And this sort of an honesty is not good for the MPC business bottom line, because forcing this technology down people's throats might actually increase my revenue in the short term. But the point is that what we'd like to do is we'd like to have them pay for upgrades in the long term. So in that sense, we'd rather focus on cases that actually would make the business pain go away. So the pain people have is, I want to launch a new service, but I can't because version A, lawyers tell me I shouldn't. My management tells me it's scary, it's creepy stuff, we shouldn't do it, or something like that. And then we come and say, okay, we can take away parts of the creepy, and we can say that the data protection thing, we can minimize the risks beyond anything that you have seen before. So you thought there were risks, there will still be risks, but we'll take them so low that we can, like, quantitatively, using some techniques, analytical techniques, show you how much lower they are, that the management would actually consider now running this service.
So it's basically, it's the standard sell of doing risk analysis and saying it's like you buy your stuff, it reduces your risk, and therefore it saves you money in the long run. Right,
but here we go for the
or allows you to, or it opens up markets that you didn't have before.
Correct. The market thing is important because, for example, when I look at the American markets, I look at the Southeast Asian markets, I look at the cool stuff they're building with services, the stuff they're doing with mobile phones. Some of that stuff might be really cool to do here in Europe, but we've shot ourselves into various feet with the Gdpr thing. And I'm a great fan of Gdpr. I can tell you more about that later. The point is that I believe we can do these things, a lot of these things, based on European values. There is at least some sort of joint European values, and I think that we could do this. Just like a lot of countries actually could come together and build contact tracing apps this year. There was even privacy involved, and that was rather successful. We built it better than the Singaporeans did, in a way, and it worked out rather fine. I take it as a great success story. So I think that we could actually do a lot more things. Now, you still have to tackle the ethics, because if the output of your very privacy preserving application says that you should discriminate on somebody, then that's still not cool. So we often find ourselves with customers who want to build something, and then we're saying that, yes, but you also need to consider that you need to limit yourself. You basically need to tie your own hands when you build this application, because other people would still say that, yes, what you can learn from this data, even if you're doing it in a privacy preserving matter, is still too creepy. So that's not a discussion that goes well with some customers, but some understand.
Good. So I'm just going to pass it over to Rob, who said he was got a few industry focused questions, but which whilst you're asking those, I can look at the other questions to see what
thanks,
people have it.
Thanks, Nigel. I think you've given us very good background there, Dan, on sort of an intro into what multi-party computation is, what Cybernetica is doing. and some of the pains you've felt, what do you think the general level of uptake of MPC is compared to what it should be? Where is MPC uptake in, you know, the world?
Well, we need to look no further than the Gartner hype cycle, of course, where MPC is on the rise. So we haven't reached full hype yet, that's for sure, and there's still a lot to teach. And teaching is one of the things that we have understood in the MPC community. And one of the things I would like to bring out here is that the MPC community has significantly grown over the years. 10 years ago, when I was the crazy one, when I went to talk to people about MPC and yeah, let's do it in practice. We have this near product thing here, so let's do innovation. Then everybody was like, yeah, those Danish folks were crazy and you are too. But these days, it's much better. There's this thing called the Mpc Alliance, or like a whole 40 companies strong industry union of companies interested in developing MPC tech, using MPC tech, popularizing MPC tech. So it has a lot of very cool names on it. Many of them are in this call today. A shout out to all of you as well. And this is exactly in a way, now we have standards coming up on MPC, and all of this is happening. So talking about MPC is not only for crazy academics anymore. And yes, it used to be. It used to be that I was like the scientist, and whenever I went somewhere, then people introduced me, here's the scientist. Now it's, I have a suit and it is somewhat better, but when I talk, I still betray myself as a scientist every now and then. When I talk about IEEE floating point precisions and things like that, that's usually a giveaway. But anyway, to go back then, I would say that we are still on the rise and there's still a long way to go. We haven't reached the blockchain levels of hype, which may be a good thing, because blockchain hype might have been a bit too high. And the other thing is that, let's say, a few years ago, I heard from, I think it was a Gartner analyst saying that non-proof of concept revenue for blockchain applications is negligible.
Yep.
I would say that today, the same rings true for MPC.
Interesting.
Non-proof of concept revenue for MPC, like general MPC, like in a grand scale, remains low. There are certain applications of MPC which are more mature and are making a lot more revenue. So Nigel might be able to name some, for example, but as MPC in general, like MPC as a technology, and I'm getting back to that. The point here is that you see procurement. You see procurement coming from agencies for privacy preserving or secure computing technology. Again, in Europe, we need to look no further than European Space Agency that has had a whole procurement on privacy preserving machine learning this year. There's been procurement from the European Statistics Office. They don't shove the technology choice down to your throat. They say that you come and tell us what you can reasonably use for our problem. Meaning that MPC finds itself in the market with multiple other techniques. Homomorphic encryption, which you will learn from the next interview that Nigel will host, and using everything else there is. So it's, in a way, MPC is a sort of one tool in a toolbox that's solving the same problem. And as such, it puts it in the position where there's a sort of a who survives and who is honest in their marketing, because there's places where homomorphic encryption is great. There's places where MPC gives you something that homomorphic encryption can't, and so on, so on. So it's an interesting developing market where there are a lot more providers than they used to. There's a lot of open source tech. There's a lot of proof of concept projects and pilots. And these are, people are paying for them. So I would say that we're in a good point where the customers are learning much more about MPC. There's much more providers, and we are getting to a point of standardization when even the terminology is being agreed upon. So I think it's a good place to be.
Okay, great.
Good. Okay, so I'm going to go to some of the questions that are becoming live, because I think some of them are kind of interesting. Okay, so someone asked, could you give a very quick overview of how MPC works? Because the kind of implication was that it might be based on trusted hardware, which is definitely not true. So could you explain roughly in 2 minutes how it works?
I'll try to do it in 2 minutes, but I have to address the trusted hardware assumption. Think of it if you have to, in your head, separate the application and the cryptographic technology. Because if you define the application as multi-party computation, as I just described in the beginning, saying that multiple people calculating something, somebody gets the result, input privacy. Yes, then there are multiple technologies to achieve that. So when you talk to a cryptographer about MPC, they will tell you that it's usually based on some things like secret sharing or garbled circuits, oblivious transfer, things like that. So the essential point is that I wouldn't be able to go through all of those in 2 minutes, but I would say that the idea for cryptographic MPC is that you apply cryptographic protection to your inputs using secret sharing or encryption of some kind, and then you provide your data to another party who processes it without ever reconstructing the values. And that's a key difference, because with trusted hardware, the values will be reconstructed, but it will be inside the trusted platform, inside the enclave, inside the trusted execution environment. And the security assumptions are wildly different, but you can achieve the same kind of application. Now, the technologies that achieve this, that you never have to decrypt, are things like, again, homomorphic secret sharing, homomorphic encryption. Note the word homomorphic. It basically tells you that if you do an operation on the encrypted data, then the result corresponds to a result on the original data you had. Meaning that, again, you never have to decrypt with cryptographic MPC. That's the beauty of it. With trusted execution environments, you have to decrypt. And once you decrypt, you are under the mercy of the gods of silicon, that whether and side channel attacks. So basically, while you can implement certain things using trusted execution environments, you will have certain security guarantees. And then they are different than what you have with pure homomorphic MPC or homomorphic encryption.
Okay, cool. Another question. You've already mentioned GDPR. So someone says, how is MPC related to international regulation like Gdpr and Ccpa and whatever DMs? Ones.
That's been basically why I've been writing so few crypto papers in the last few years. You know, Nigel, that this year I published my first law paper, actually. So
that's going to be the next question. So there we go. Carry on. So you can answer two in one.
Yeah. So point is, if you look at the GDPR, then the GDPR recital 26 kind of suggests that whatever you use to make sure that data cannot be re-identified could be considered anonymization, which means that technically MPC, if done right, could be anonymization under the GDPR, which is sort of like the Holy Grail, because it gives you a chance of, hey, that's almost a get out of jail free card under GDPR. However, when you talk to legal scholars, then there's this school of thought that if an MPC host as a party has some control over what kind of processing takes place, then they might still be a joint controller. And this made sense to those of you who understand the GDPR in good detail. And for the rest of us, consider it the fact that MPC will hide the data from you, from the host, the service provider. But the service provider will still be able to say which kind of code runs, which kind of algorithms run. And that might give you this interesting situation where part of GDPR says that, haha, you're the controller, means that you have all the responsibilities of a controller. But part of the GDPR says that, yeah, that's anonymous data, we don't really care about that. So that's the interesting part. And I'm trying to argue for the fact that actually MPC achieves better anonymization than anything else that's currently available, because most of the other stuff can be broken way more easily.
Okay, so yeah, we know SGX is broken. So you talked about law. So one of the questions is, what's the conversation between lawmakers, regulators, to mandate adoption of MPC or PEP types systems for industries, especially the regulated industries or industries which are national critical infrastructure?
Right. It comes down to what's the state of the art. And GDPR doesn't tell you which privacy technology to use, which is rather nice, because if tomorrow Nigel comes up with something that's better than MPC, I don't know, maybe that's still your best thing. But if that happens, then technically GDPR shouldn't force you to use MPC. It should say that CPM is much better. So that's the point. So GDPR tells you you have to follow the state of the art. And if the state of the art among financial regulators says that, so we now do bank stress tests using MPC, then that's going to be the state of the art. So if you get broken into and you didn't use MPC, then you'll be liable for not using MPC. But there will probably be no mandate of using technology. There is one interesting attempt in the US to use MPC or similar technology to mandate the processing of university students' salary data, to actually say what's the actual, let's say, return of investment for going to a particular institution of higher education. But at least with the current Senate, Congress, and President combination, it hasn't really gone very far. Might be this changes, but very few have been brave enough to actually try to put MPC inside a regulation, and I'm not sure whether that's the best idea.
It's interesting you mentioned stress testing, because I read a paper by Marcella Hastings the other week where she looks at actually doing stress testing for banks using MPC, because the issue is that you stress test a single bank and you don't really see the exposure of its liquidity problem, because actually it's the systemic loss is the problem, not the individual bank. And the individual bank might fail because someone else is failing in the system. So that's quite interesting. Okay, so other questions. Yeah, sorry, carry on.
Go on.
All right, other questions we have is, I want to kind of keep on the questions so that I know the answer to these questions, but I want, obviously the audience doesn't, so it's kind of, so I'm kind of choosing the questions so that people get a very good clarity of the technology. So one question we have is it possible to ensure that one party actually follows the protocol or the function to be applied? How do you stop people doing the wrong thing?
There's multiple ways for that. There's proactive and reactive ways. Each of them comes at a cost. Meaning that if you're proactive, you try to build the protocol in such a way that a misbehaving MPC host gets caught by the others. They can't follow through with a certain proof or a certain part of the protocol, so they will be detected. Now, this is obviously something that adds to the complexity of the protocol, and although the cost of these protocols has been brought rather low, then it depends in the end on your economics of your application and the complexity. It adds quite a lot to the technical base you need to have implemented, and the maturity of these implementations is getting better by the day as better implementations are written by all of Nigel's postdocs and docs and ex-PhD students. But it's something that, as an interesting fact, I've never seen a customer yet that would ask for, let's say, that knows, some of them, there's like two categories of MPC customers. Some of them are ex-MPC researchers, and they say, we obviously need to have security against an active adversary who can cheat. And then I ask them, so what's the business model? Why do you need it? We don't have a business model yet, and but we are sure we need that one. And the others are like, okay, this is the business problem I need to solve. Let's build from this. We have this kind of organization, this kind of governance model. This is what we're willing to pay for. And yeah.
Okay, so if anyone's out there, to the phrases that you need to use when you talk to these providers, if you didn't know it, is if you want something that protects against people cheating when they run the protocol, you want something that's called actively secure or maliciously secure. And it's a bit like when you go to the website, it says this website has been secured with 256-bit encryption. It's the difference between 256-bit encryption and 128-bit encryption. It's a bit more sales pitch, if you see what I mean. So
yeah, there is a technical difference, but when it comes down to the attacks and the cost of an actual attack, which is something that we actually sometimes calculate for a customer, saying that what's the actual cost of attack? What's the cost difference in attack and what's the cost difference in defense, then sometimes the economics don't justify this.
Given that, it's another really cool question here. Given that the people you're selling to are not going to be cryptographic experts,
yes,
and you're basically selling them something that's magic, it allows them to compute on stuff that they don't see, right? How do you convince them that you're not cheating? How do you convince them that it is actually secure in the long run?
Right. So there's a combination of techniques which every security technology vendor has to apply at some point, which ranges from audits, certification. There is no certification currently for Mpc systems. We've considered what it would cost to have common criteria certified Mpc systems, and think it would cost somewhere north of 2-3 million euros or pounds or what have you. Just to, first of all, find a certification body who would be willing to understand what's the crazy thing that you're trying to certify, and write the protection profile with you. Because the first
I think the only one I know of is in this space is Enveil, which has common criteria for its homomorphic encryption, one of its homomorphic encryption products. But there's nothing in, you know, okay, so Unbound's got FIPS certification, but that's for a very, very different use case from what you're talking about. So
right.
It's really, really hard. Yeah, yeah.
And homomorphic encryption is slightly easier because it has less parties and less moving pieces. The main cryptographic primitive you're using with homomorphic encryption is homomorphic encryption. It's just that. Whereas if you're building something on top of MPC, then the number of moving parts in a modern maliciously secure MPC system is mind-boggling. So in a way, the complexity is always not a good thing, while even the result has to justify that complexity. So the other aspects obviously are, you have to be able to explain. That's why I'm using a specific 5-minute slide where I use little small number mathematics. I explain how this works. I've been able to explain this to CEOs because everybody understands this much math. And then when they look at this, they build this mental model on how this works. And then when they start asking questions about, hey, but what if this party does that? Then I know that I've won. They now understand it. And then when I can show in the implementation that, see, that's the database of one of the nodes, and everything you see inside here is rubbish, it's total gibberish, randomness. Then they see, it's like on that slide there. So teaching education is key. And again, this is where I hope Mpc Alliance will make some global success happen, because I can't go and show that slide to everybody.
Okay, so there's a really cool one here from Richard Pinch. Always good questions from Richard. So you've talked about formal certification of product. Should there be a formal certification of cryptographers or security providers?
Yes.
So do we need a chartered cryptographer status?
There are things. There are all these. There's a ton of certifications for security people, and there's a funny story. Rather recently, still earlier this year, before when it was still okay to fly, I was explaining ShareMine to a security auditor who came in and tried to compare our ShareMine design to an industry best practice, and they had a lot of trouble understanding what we're doing, because for half the questions we said that it's not in our attack surface because you can't mount this attack reasonably. Because a lot of things were like, no, we're not doing anything against that, because you can't mount this attack against an MPC system because you don't have access to that data. And then they were trying to figure out whether we were super compliant or super uncompliant. Yeah. So it was a very hard thing. In the end, they said that we got very high grades on cryptography, but not very high grades on things like data leakage prevention. So yeah, exactly.
I mean, whereas NIST is actually looking. I mean, there was like 2 weeks ago, there was a NIST thing, which is actually to use a meeting, which is to look at using MPC as a way of actually stopping data leakage prevention. I mean, it's just like
no. Thing is, you know what data leakage prevention is in enterprise security. It's a very specific kind of product. And we're not using it because the threat model doesn't necessitate it. But if you go with a standard, like a standard with, you know, these radars are made, how strong you are here, then their enterprise security model said that you have to have DLP if you're doing this sort of healthcare data processing. And we didn't have it, so we got low grades there, even though technically, and we got a senior auditor. He said, I really understand what you're doing, but the model is so new. In the sense, so that's why, again, education, and talking about it. And in the future, I'm hoping that the audit guidelines and the security models will change, and standardization is a very key step towards that. So in that day, we got off well because the customer said, okay, we understand you went slightly deeper. It was not just a check the boxes kind of security audit. You actually tried to understand the system, which was great. So yes, certified cryptographers is nice. And the problem we're starting to have is some people who have taken ShareMine, maybe even as an academic license, and used it totally incorrectly. So for example, building a prototype, a system where you calculate everything securely to the end, and then you publish the secure inputs just, you know, because your application says that you should. And they say, but ShareMine makes it secure. No, it doesn't. You just run your data through a very complicated machine and then published it anyway. So, and we've actually had to publish some papers saying that what they are doing is not the correct way for doing things with MPC.
Yeah, you have to have applications where the application is itself by definition insecure, no matter how much security you throw at it.
Correct.
Okay, so going back to, there's a couple of questions related to it's multi-party computation. So the question is how many parties? So there's two related questions here. Is what do you see as the number of parties that you're seeing in your customers? And what is the maximum number of parties that you think can run a sensible computation at the moment? Where sensible, you can define however you want.
Right. So let's go with, there's two different questions here. You have to think of how many input parties there are and how many computing parties, and that's a key differentiation. So let's address these things separately. And a reasonable MPC application today can have any number of input parties. So really, that should not be the challenge. However, in many cases, companies like to run these one-on-one, these bilateral protocols. So me comparing something against you, us comparing a set intersection, a common subset, something like that. So one-on-one computations, this is a popular model in data, at least. Then where we are trying to build new versions of existing services, like services you haven't really thought of, that you can imagine, but we're building them on top of MPC. These service models typically assume that there's a central service provider. So with MPC, we're replacing that central service provider with a number of computing parties, none of whom has total control over the data. And then it comes down to the governance of the central party. And I would say that 2- and 3-party systems and increasingly 4-party systems are showing promise. 2, because it's the least possible where you still have multi. 3, where the protocols are simple, rather elegant and well performing. And 4, where you can start throwing in some fancy additional security guarantees and retain some of the elegance. So we can build an N-party MPC system, and very cool ones have been built for specific applications. If you look at some of the cryptocurrency thing, the Zcash ritual, which they use to decide on their zero knowledge common reference strings and things like that, that was very cool, very impressive, very bespoke. If you want something generic, then less is better, because the governance models will kill the application with their complexity if it's too much. And yes, in MPC, it sometimes takes 3 to tango. It's an interesting kind of tango, but it's a pragmatic kind.
Okay, so really cool. Every time you answer a question, you kind of always lead on to the next one I was going to ask. So you mentioned there blockchain and cryptocurrencies and Zcash. So there's a lot of questions we've got here, which are kind of on this interface between blockchain and MPC, because we know there are applications of MPC within blockchain. I mean, there's applications of MPC to blockchain in terms of securing keys, and there's a lot of companies in that space. There's a lot of, but there's a lot of things where blockchain is about distributed. It's about distributed data. It's about, you know, removing the central authority and stuff like that. So putting aside the applications of MPC to securing the blockchain as it is, yeah. So the traditional threshold signatures, what interaction are you seeing between the blockchain world and the MPC world?
In ShareMind, we have actually used permission blockchain timestamping style stuff for audit logging. It's a sort of an additional security guarantee on the audit log, because again, we are building something that needs to be trusted, and we need to prove later what we calculated, when we calculated, and all of that black boxness of MPC means that we have to provide transparency using other means. And having a log on blockchain of some kind is not an unreasonable thing to do. However, and there's also this whole programmable economy thing where people are trying to build blockchains where you have this data on the blockchain and computation on the blockchain, and everything runs on MPC. Very cool models. Some of them almost barely work. Some of them have actually pivoted to other technologies when they understood that they're building a very complicated box nobody will understand in the end. And I would say that in a way, blockchain achieves a different security guarantee, which is integrity, and MPC gives you confidentiality and a certain kind of integrity. There, you can marry them together, and then you need to look at what's the business case. Just having them together because it's cool does not usually make economic sense.
Okay, so we talked there about MPC and the other thing on the hype cycle, which is blockchain. Okay, there's one other thing which is normally on the crypto hype cycle, which is post-quantum. Okay, so what did you say, sorry?
Yeah, that's right. I agree with you.
Okay, right. Sorry. Yeah. So how does, so we've got some questions on how does MPC play with post-quantum? What happens if someone builds a quantum computer tomorrow? What happens to the MPC systems at that point?
Right. Really depends on what kind of MPC protocols you're working on. Some of the nice, I'm using a new term now, information theoretically secure stuff, which uses simpler math, less math. These will be okay because the only crypto they use is for secure transport and secure random number generation. You can build a post-quantum, you can plug in a post-quantum secure channel. You can do it today with the TLS, use some post-quantum PKI stuff, and you're good to go. And you can generate post-quantum random numbers if you really want to. So that's doable. Certain things will certainly survive. Certain things that are based on today's public key crypto, such as RSA or things like that, might have a worse time. However, good news, fully homomorphic encryption stuff tends to be based on, some of it is based on lattices, which are rather post-quantum with some luck, you know. Depends on how you set them up, and understanding the security parameters has become a lot better over the last years. Still, some are not fully convinced, but we'll get there, hopefully.
Okay. So a nice question here is, how to phrase this? You talked at the beginning about there's not that many use cases which are actually in production and are out of POC phase. So what use cases do you know of that are in production that are generating revenue, or not necessarily generating revenue, but actually in production and deployed? Because you could actually deploy an NPC system not to generate revenue, yeah? So let's exclude the generate revenue thing, but which ones are actually deployed that you know of, or you could talk about?
Yes, everything I'm now going to say is based on public information, so take it with a grain of salt, and people's PR departments can be aggressive when they say this. I've seen quite a lot of news about using MPC for healthcare applications. People write papers, they have press releases, they say that even like MPC based COVID contact tracing apps, and NPC-based genome studies, things like that. People say they're doing those, so we've done them as well as proofs of concept. We haven't had a full, let's say, production case genomic application yet. So our areas where we focus in our production currently are not so much ongoing running services. These days we do quite, because our focus is on data analytics with ShareMind, then we do this, help people do analytical projects. You do a sort of extract, transform, load data project, you get some data together, you get the results, and not always does this become a running service that is run every year. Much like the sugar beet auction, technically you run it once a year and then you're done. The last time I asked the Danish folks, they said that this still is running. But this is a couple of years ago, so I don't know whether they had a COVID compliant sugar beet auction as well. I'm hoping they did. That would be rather cool. These people are heroes in my book. So really, when you talk about ongoing like services, whether I could go today and do something, then I believe the Tor network is using MPC for certain statistics and metrics. And there was this news like in this week where certain, again, metrics and aggregation for like websites and things like that, the PRIO thing.
Oh, PRIO thing, PRIO, yeah.
Yeah, where that's, I think, based on some sort of, some form of MPC. So if you want to build metrics into your whatever website system, then there is this thing called PRIO, who nicely announced this week, has been development over some years now, which you should certainly take a look at. It's something from the same people that bring you let's encrypt TLS keys. Yeah.
And we can say that securing cryptographic keys is as a deployed solution. So we know that.
Yes, obviously. I was assuming that you would go for that one. There's a number of companies providing that.
There's a number of companies providing that. Yeah, exactly. Okay, so let's go down. We've talked about post-quantum. Oh yes, so again, you mentioned data analytics. So a few of the questions are related to machine learning. So what do you see MPC helping in machine learning? Now, I think we should divide the conversation here between learning a model and evaluating the model, because these are very different things. And I think we're going to touch on that a lot more next week when we talk about homomorphic encryption. So I think it's really, to set the scene for next week, it's quite a good idea to actually kind of like talk about this difference between learning and evaluation.
So that's the funny thing. When a lot of the projects, some of the projects I'm currently related to are to do with healthcare data and building models and services on healthcare data. And then the thing is that we do not have specialists who are capable of building machine learning models using privacy enhancing technologies. It's not something that people are taught very well. When they come out of the universities, they assume that they will have all the data forever. And this is something that the educational system will hopefully fix in 20 years or so. But right now, exactly as Nigel said, the training part often is done on some sort of anonymized data, where your definition of anonymized depends on what you are going to get away with. And that's a reasonable thing to do, because again, we have seen it a number of times. For exploratory data analysis, secure computing solutions are not perfectly elegant. We have built exploratory data analytics support into ShareMind. We have basically a full statistical suite of tools. You can do this outlier detection, outlier removal. You can do linear regression, logistic regression, everything on MPC. We have implemented that on ShareMind. But the thing is that sometimes the statistician will tell you, but I need to see the data, even though they won't really do any math in their head, but sort of it gives them a feeling. And we're not always fighting that. That's actually one of the barriers we've seen. So when you have a model, you have implemented it, you have trained it, and running a model on MPC is totally reasonable. It makes perfect business sense. It's computation that will rarely change unless you build a new version. And with MPC, one of the things that you should also consider is ideally you don't change the MPC application every week. because technically for the best security, every party in an MPC system should be responsible for what's being computed. And if somebody can arbitrarily upload new algorithms and new query code at their will, then technically they can void the MPC security guarantee in a second. They'll just upload a query that outputs the private data, and poof, you've lost. Yeah. So the thing is that in exploratory data analytics, unless really mandated by somebody, I would try to go for non-MPC solutions and then use MPC in production.
There's a kind of cool story I got here that almost 95% of data analytics in industry is not using machine learning. It really is not what you call exploratory analytics. It's what's called exploratory statistics. It's actually doing a mean, a standard deviation, and a pie chart. If you're lucky,
we can all do. We can do all of that.
If you're lucky. So I was in a meeting with, I won't embarrass them by the agency who it was, and they said, can we do a multivariate statistics? And I thought they want to do generalized linear models and all this stuff. Oh no, you're never going to be able to do multivariate statistics. Now, what they meant by multivariate statistics was a table with 2 rows opposed to just 1 row and multiple columns. So it meant a database table with 2 rows as opposed to just 1 row. So it's kind of like that was a huge statistics agency asking that. So it's kind of very simple statistics are 95% of what goes on in the real world. So I think ML's kind of like blockchain is oversold. So. It is.
Just as a sort of a humble, not so humble brag, then our Tax Plus education study, we had 10 million records, 50 attributes each row. So this was something, the data management is something which is sometimes hard on secure computing, because you also need to do your group by and your sorting and your linking and all of that. So we also have things for that. So in a way, building an end-to-end system is sometimes easier with MPC than with bespoke protocols, because bespoke protocols don't always compose. You may be able to do one operation, but you can't immediately reuse your result in the next secure protocol, for example.
So another really cool question here, which I don't know what the answer is going to be, is what is the most tenuous or bizarre application of MPC you've seen?
There have been several. People have been trying to do rather weird stuff. You should have given me that in advance, because
it only just came up.
There's stuff that we've been like. There's been stuff like, are you out of your mind? Basically, it's been some. Usually, advertising people try to do weird stuff like marketing. There's sort of some things that they want to do, even I can't make ethical or I can't make private, because some of the things are creepy from that regard. But when it comes to things like the deployments have sometimes been very funny. So yes, I want to deploy some things here, some things there, some things on a phone, and some things elsewhere. And actually, I want to run it all in a single organization. Well, then again, that's not always crazy, because Cybernetica runs its employee satisfaction surveys on ShareMind with random employees from different departments running ShareMind nodes, for example. So it's not always crazy, but the deployment models are sometimes rather funny. So sorry, okay. I can't answer that question. I don't remember the good ones.
Okay, so we'll leave that maybe on Twitter later. But I just thought it was such a cool question. It just had to be asked. Okay, so I think we're kind of wrapping up, but so as to make a bridge to next week, what I'd like to wrap up with is with this question. So next week, we're going to be talking about homomorphic encryption, okay, which is completely different. So what I would like you to do is give us some comparisons that people can use to say, what's the difference between MPC and homomorphic encryption in terms of use cases and in terms of the infrastructure or the architecture to be using? Where do you pay with MPC that you don't pay with FHE? Where do you pay with FHE you don't pay with MPC? And so on, just to put them all, just so for the conversation next week can be put into context with what the one is today.
Right. With MPC, you have a service provider that is distributed, meaning that no single party will be able to affect what's going on. They need to have some sort of consensus
during computation.
during computation.
Yeah.
Homomorphic does not have that restriction. Homomorphic is by definition passively secure in a way. But it goes on. There's things like zero knowledge, which we're increasingly working on these days.
That's in 3 weeks' time.
Yes, I knew that. That's why I was planning to name drop this. So zero knowledge solves a problem that you could also solve with MPC, and in some cases you should, and in some cases you will. But in zero knowledge, you actually are trying to have a very specific kind of computation, and zero knowledge can make it, again, in a more elegant way than MPC specifically. So, and then again, I just have to say this. There's this SGX thing, which the cryptographers don't like, and everybody says it's broken. But the problem is someday they might actually get it to work with reasonable boundaries. And yes, that's going to be the question of if it's going to be more expensive to break SGX than it will be to just get your hands on the data through some other way, then the problem will be that it will have a business effect. And I'm going to be very honest saying that in Cybernetica, because Cybernetica plays with a lot of technologies, and Cybernetica is playing both hands right now for the pragmatic reasons of business. Okay. And,
so we should kind of wrap up. But I just want to say before we wrap up, before we thank everybody, okay, that we've been focusing on Cybernetica today, but in an MPC space, there is in the privacy enhancing part of the MPC space, there are a lot of companies out there. We've mentioned the Danish sugar beet people. They also do other things. The company, if you want to look them up, is Partisia. There's companies in Switzerland. There's a company called Infer in Switzerland. There's a company, Cosmian in France. There's a bunch of other people around in the privacy enhancing technology. Alibaba are doing stuff in this space. Facebook are doing stuff in this space. Google are doing stuff in this space. Everybody's doing stuff in this space. So of the big companies, Microsoft, we've got a big office out in India looking at MPC. So we're not just, well, we focused on Dan. It doesn't, and if you're a representative of another company that does MPC for privacy enhancing technologies, we're sorry we didn't invite you. We could only invite one person, so that's why I invited Dan. So, and I want to end this by thanking Dan. That was a really, really cool conversation. We've had loads of questions on the Q&A, which we haven't managed to get through. I've just been picking them at random sometimes. There's a lot of people have asked, are we going to put the video up online? The video will be on the Newton Gateway website at some point once it's been cleaned, edited and done properly. But thank you all. And Rob, do you want to say anything before we sign off?
I guess so. I guess I'll leave with your thoughts, Dan and Nigel, if that's okay. So you're sat there in a room full of companies who have now heard about MPC. They're now interested in it. What's the first thing they should do? And is there a message you want to give them about MPC?
Yes. So first of all, do know that there's a number of providers. You will be able to select from many. You can ask on Twitter, the Mpc Alliance website. If you do Mpc Alliance in a search, you will find them. There's a nice big list of companies. Some of them do data, some of them do keys. You will be able to ask them. First step is to understand why you are doing this. What are you planning to get out of it? And we can help you. Any of these companies can help you figure this out. Understand what's the problem you're solving. If it's a privacy problem, we can help. If it's an ethics problem, you will need to solve that on your own still. And understanding your business process is key. What data moves from where to where? Because in our work, we even developed this privacy enhanced business process modeling notation to understand how people actually move data in their business models so that we would know where to plug in certain privacy technologies. So if you understand your data flows, it will make it a lot easier for us.
Brilliant.
And thank you everybody. And thank you everybody as well. Great questions from Nigel, great from everybody listening. And everybody in the audience who are working on MPC, I would like to say thank you. It was so, I felt very alone 10 years ago. I don't anymore.
Okay. So to let everybody know in the audience, that's the mpcalliance.org. You can look up, and as Dan says, covers stuff on the privacy enhancing technology side of the house, where Mpc, which is what we're focused on today, but also looks at Alliance also includes companies that are looking at using Mpc to do secure and cryptographic keys, of which there are a number. What we're doing in, I think, a week's time is November the 30th, which might not be a week's time. It's probably just over a week's time, isn't it? Yeah, on November the 30th, we have another Newton Institute thing, which is going to be talking about fully homomorphic encryption. And we're going to have Rand Hindi from Zama, which is a French company, French startup. And they're going to be talking about how they're using homomorphic encryption, particularly in the machine learning area, which is going to be interesting to people, neural networks, etc. And then after that, we're going to have Elie Ben-Sasson from Startware is going to be talking about zero knowledge proof. So all of you blockchain people should definitely turn into that. And then after that, we've got a fourth one, which is going to be on, we're going to have some people who want to use privacy enhancing technologies, and we're going to see it from the other side, not the provider side, but from the customer's point of view, what they want, how they want to deploy these, what the barriers they see. And then finally, after Christmas, because a number of people, when we announced this, said it would be a really cool idea, we're actually got another call where we're going to be talking to 3 kind of investors in the space and board level people to kind of have a look at it from the C-level suite perspective and the investment perspective of where the opportunities are going forward. So thanks everybody, thanks to Newton Gateway, it's run smoothly as ever, totally brilliantly organised by Claire, Lizzie, Jane and Arnell and everybody, big round of applause to them. And thank you all for, thanks, we can all see Arnell and go, thank you, he's the IT support guy. Thank you, and we'll see you all at the next meeting. Bye.